Hello and welcome guys. So in the last video we completed our text vectorization part. So in that we developed this text vectorization layer, and after that we did some deep diving. So I have given here markdown that what exactly we are doing. So let me put this also in this cell. So in this cell we are building this text vectorization layer, and then we are running each and everything, like what is this vectorization layer and how it works. So all these things we saw in the last video. Okay, we got our text vectorization layer. Now we have to build our embedding layer, and after that we are ready to build our LSTM model. First let me tell you so why we require that embedding layer. So before that, let me show you my training set. So training set is basically in text form like this. Okay, and after that we develop this text vectorization layer. So where what we are doing, we are taking each word and we are giving some unique number to it. Okay, and this unique number is basically the index of the vocabulary list. Okay, so the index of that particular word like really is present at 15th index in this vocabulary, and those words which are not part of this vocab array, that we are giving to unknown. Okay, like here this one is 1. Okay, so that we are pointing to 1 index, and 0 means that we don't have that value, so that's why 0 dedicated to empty. Okay, so here we have defined the fixed size, like we can only process maximum 200 length of tokens. Tokens means words. Okay, so we can process maximum 200 words here. Okay, so we got our unique numbers, but this is not embedding. This we are not going to feed to our LSTM network, because if we are going to feed this to our LSTM network, then it has no sense. It will not understand what is the meaning of really, what is this wanted. It will not be able to identify the relationship between the words. Okay, so for that first we have to convert it into embedding. We will see that how we can build embedding on the top of this. And in generative AI term, if you are a generative AI enthusiast and you want to learn generative AI, then this is the foundation of generative AI. So whatever we did here, this text vectorization is basically the tokenization. So in language model like OpenAI or Claude or any language model if you're using, or any transformer model, anything you are using, so first you there also we do tokenization, and then we build embedding. So tokenization is basically what we did here using TensorFlow text vectorization. Okay, so using TensorFlow text vectorization, we converted those words into unique numbers. So this is the tokenization. So we got our token. Now we will see how we can build embedding layer. Okay, so I'm giving here one markdown as building embedding layer. Okay, so first let me show you how we can build our embedding layer. So let me go to the documentation of TensorFlow. So I will provide the link of this in the video description, so you can take from there. So this is, so you can call your embedding using tf.keras.layers.embedding. So this will accept input dim, output dim, and embedding initializer is also there, regularizer is there. So exactly what is the meaning of these things? So input dim means the size of your vocabulary. So basically what is your size? So yeah, we will give this thing. And output dim is the dimension of the dense embedding. So whatever embedding you are creating using this embedding layer, so how much you want the dimension of that embedding. So that is the meaning of this. And embedding initializer is the matrix. So you can initialize your embedding matrix, or if you are not initializing it, then it will randomly initialize the matrix, and later if you are training it with your LSTM model, then this matrix will get fine-tuned with your LSTM model. So you have two options. So you can select any of this. So in version 1 of this project, we will not use this embedding initializer. We will randomly initialize something, and we'll start with that, and later we will also explore this embedding initializer and what is the significance of embedding initializer. We will discuss these things also in the upcoming videos. Okay, so this is the meaning of that. So let me take this from here and let me show you. So basically we need right now these two arguments. Rest all I am putting as default. Okay, for that first you have to initialize it from tensorflow.keras.layers you have to do, and from there you have to import embedding, and embed is equal to, here you have to give this embedding, and in this first you have to pass this input dim. Okay, so input dim is basically your vocab size, so you can take vocab size from here. So this is your vocab, and if you take the length of this, then you will get your vocab. Okay, so 20,000 we have already defined our vocab size, so this is your vocab size, and the second parameter is your output dim, so you can take this from here. So output dim is basically how much dimension you want in your embedding. So for each word, how much number of feature you want. So I'm giving right now as 100. You can give any number. Okay, so we got our embedding. So if you print here, then you will see this embedding has been created. You can test by taking something like I'm taking this example. So this embedding will take input as this vectorized part. Okay, so this is our X train. So first we'll take this raw text and we'll feed to this text vectorization layer, and from there we'll get this unique values. Okay, unique numbers we'll get. So after that we'll take this unique number and we'll feed to this embedding layer. Okay, so in this I'm feeding this unique number. If I print here this thing, so this is a unique number, so I'm feeding this unique number to this embedding layer. So I'm getting like this. Okay, so if you see here, the dimension of this data, this particular example is 200, and here I'm getting 200 cross 100. Okay, so basically for each word we have this 100 vector. Okay, and this 100 vector is basically the feature of that particular word. Okay, like let me, if I take one example like king, so king has some features like king is, if I'm saying king, then definitely it is male, so male is one feature for king. And royal, yes, he is royal, so royal is another feature. And king is rich, yeah, that is also one feature. King is powerful, that is also one feature. And same for queen also. For queen is female, something like that. And queen is beautiful, that is also one feature. So like that you have different features. So we are representing each word in 100 different feature. So this is 100 different feature of this word. Okay, and now if we feed this vector, this particular vector to LSTM model, then definitely model will learn and understand these text and words correctly, and it will identify the pattern. Okay, so these are the feature I have for this particular word. So with that it will understand it better. Okay, so that's why this embedding is important. Okay, so now you know that how you can create this embedding layer and how you can create this text vectorization layer. So now we'll use these two things to build our LSTM model. Okay, first before building LSTM model, you have to understand why we are using LSTM model here in this project. Okay, so LSTM model is a type of neural network which is designed to process sequential data where sequence matters. So in text, sequences of word is very important. If you change the sequence of word, then the entire meaning of text will get changed. Okay, so that's why, so in this type of problem where sequence matter, where orders matter, so there we have to use LSTM neural network. And if you want to learn more about LSTM neural network, then you can go here, LSTM tutorial. So this is one blog which you can read and learn that exactly how LSTM neural network works and what is LSTM, why we need LSTM. So you can learn all these basics from here. And if you deep dive in more mathematically, more generative AI friendly, then you can go to RNN cheat sheet from Stanford. So this I have already used for convolutional neural network. So in this cheat sheet you will find convolutional neural network. This I already explained in my convolutional neural network playlist, so you can take from there. So convolutional neural network is basically designed to process where we have to extract the spatial feature from the data. Like if we are doing any image recognition thing or something, then from in that we have to extract important feature from that particular image. Okay. And recurrent neural network is basically designed to process sequential data where sequences and orders matter, where previous thing is related to upcoming things. So something like that. So there we have to use recurrent neural network, and you can also see the maths behind this. So x1, x2, x3, these are the sequences. Like if I'm taking the example in my here, the movie was good or the movie was amazing. So the is x1, movie is x2, was is something, and amazing is xt. So something like that. So sequentially we will pass this information to our neural network, and we will also retain some information. So here if you see, when I'm passing here x1, then while processing x2 I'm also taking some information of x1. Okay, then I'm processing x2 along with some previous information of x1. So same when I'm processing xt, then I'm taking previous information which is coming in this variable 80 minus 1. Okay, so I'm processing current information along with previous information. So that is how recurrent neural network works. And these are the types of recurrent neural network we have. Like for music generation, we can use one-to-many neural network, in which we'll give something and we want music, so it will be in sequence. And for sentiment analysis, which we are solving right now, so this is many to one. We have to build many to one neural network in which we have many features, like the movie was amazing, and we have only one output, whether it is positive or negative. Okay, so that's why it is many to one neural network. So same for machine translation, this is many to many neural network. Like if we are processing something like English to Hindi or something, English to French, then we have certain number of feature here, and in our output also we have certain number of features. And this is how you can calculate loss function, and this is the formula used to update the weights using backpropagation algorithm. And these are the activation function which we are using to add non-linearity in the neural networks. And this is all about vanishing gradient and exploding gradient problem. So you can learn all these things in detail if you go through these things. Okay, and let me go to my VS Code. So this is the architecture of our simple architecture of our LSTM neural network. Now we'll start building our model. Okay, so first we'll initialize our model. So before that I have to import sequential. So from tensorflow.keras.models I will import sequential. Okay, and I will initialize my model by giving here sequential. Okay, so this is my sequential, and in this I will add few things. So I'm creating here one pipeline. So first I'm adding here from model.add I'm doing. So first I have to tell to this in this architecture that it has to accept things in string. Okay, so for that I will use TensorFlow again. TensorFlow.keras I will use. Okay, let me do one thing. I will define here. So from TensorFlow.keras import, I'm importing input. Okay, from TensorFlow.keras I am importing input, and I will use directly here. Okay, so in this input I will say that shape of this input will be 1, and I will give the D type. D type is basically what is the data type of that. So I'm saying that it will be of string type. So I'm giving here tf.string. Okay, so I'm saying here that input will be minimum it contain 1 character, and definitely all the training set will be of string type. Okay, and after that what I'm saying, after that I'm saying that model.add I'm doing, and in this I'm passing my vectorized layer. So vectorized layer I have already defined here. So this is my vectorized layer. So this entire cell represent vectorized layer. So I already have my vectorized layer. So let me check if I have or not. So I can do like this. So yeah, I have this vectorized layer loaded. So I'm using this vectorized layer directly here. Okay, so while training the model, first it will come here and it will check, okay, we have string, okay, good. And after that it will come here and vectorized layer will vectorize that particular text. Okay, and after that we have to add our embedding layer. So for that I will give here model.add, and I will use directly this embedding class. Okay, I will not use these things. I will directly define inside this. You can use that also. So in that I will write my vocab size, and vocab size is I think 20,000. Yes. So I will pass vocab size here, and second argument will be my input dim, which is 100. Sorry, output dim, which is 100. So here we have this 100 output dim and input dim. So you can write this thing also here, no issue. So this is your input, and I'm talking about output. So this is your output. Okay, so input dim is this much, output dim is this much, and after that I will add my LSTM layer. So model.add I will do, and in this I have to add my LSTM layer. So for that first I have to load that. So from Tensorflow dot keras dot layers I'm importing LSTM, and I will also import dense layer, and I will also import dropout layer to add dropout. Yeah, so that's what we need. Okay, so I will add here LSTM, and model.add I'm writing here, and in this I will define dense. Okay, after LSTM I want some dense neural network also. So in dense layer I am giving here 64, and these all parameter I am giving I have already tried on different parameters, so I am getting good result on this. That's why I am giving this. And after that I will define here model.dropout. So in this I will give my dropout layer. So dropout I want to give here 0.5, and then I will give my final layer. This is my final output layer which contain 1. So I want 1 neuron, because here we are building many to 1 neural network. And activation I will define it as sigmoid. Why sigmoid? Because here we are solving binary classification problem where we want answer in the form of 0 or 1. 1 means positive, 0 means negative, something like that. So that's why I am doing like this, and I am doing here model.summary to check the model. Okay, let me run this. So I'm getting my this 7.96 MB model here. So it has this text vectorization having shape this 200, because we have defined in the vectorization part this 200, and this is the embedding layer which is having this thing. So basically it will generate 200 cross. So for all 200 values coming from text vectorization, it will generate 100 different features. Okay, and we are processing this using this LSTM layer which is having 100 neurons, and then we have this dense layer, then we have this dropout, then we have a final dense layer which is output layer having neuron 1. Okay, so we got our this thing, we got our model. Now we'll compile it. So in compilation part we have to define loss function and optimizers. So optimizer I'm giving here tf.keras I'm using, tf.keras.optimizers I'm using, and dot legacy I will give here, but you don't give this. I'm using Mac, and in my my machine legacy optimizes the process, so that's why I'm using here legacy. And in this I will define learning rate. So learning rate I'm giving as 0.001, and second will be my loss function. Which loss function I want to use here? So I will use binary cross entropy loss, because here we are solving binary classification problem, so we need binary cross entropy loss here. And metrics, so metrics will be accuracy. So we successfully compiled our model. So I think that's all for this video. In the next video we will do training of the model, so we'll see in the next video. Okay, so in this video what we did, so we first understand about this text vectorization layer and embedding layer, how exactly these things works. And also we discussed that how in the context of generative AI, this tokenization is basically the text vectorization, and this embedding is the next process after tokenization. And after that, we developed here this LSTM neural network, where we added first this vectorized layer and then embedding layer and then this LSTM layer. So this is our model. So all this parameter I have already tested previously, so I'm getting good result on this, so that's why I'm using this. And then I compile this model by passing my optimizers and loss function, and then we are ready for the model training. So in the next video, we'll do the model training and also we'll do the visualization of training, and then we'll see that how models performing on this architecture. Okay, so that's all for this video. Thank you guys. Thanks a lot for watching this video. We'll meet in next video.